So we'll have the keynote speech by Interswitch, Mr. Olubiyi. All right. We'll have his profile read by Mrs. Comfort Lawal before his presentation. Thank you.
Good evening, everyone. We are delighted to have Mr. Suliaman with us this morning. Okay, so please can you rise while I read this short profile? Thank you. Okay, so Mr. Suliaman is a senior network and security engineer. He has a comprehensive background in cloud infrastructure, engineering, and security automation, with extensive hands-on experience across leading cloud platforms, including Amazon Web Services, Google Cloud Platform. He has played roles in designing and securing production-grade networks and cloud-native application for enterprise environment. I thought we were going to put our hands together. That's a lot. It encompasses cloud security architecture, network automation, hybrid network design, identity and access management. He has also made significant contribution to internal tooling initiatives with a particular focus on automated security compliance frameworks that enhance operational efficiency and risk management. Beyond his technical work, he's passionate about cloud and security education, and as an AWS community builder, he has actively contributed to knowledge sharing within the tech community with a focus on making complex cloud and security concepts more accessible. So you will agree with me that we did not just select people, we picked the best of the best. So a round of applause again for him.
Yeah, good morning, everyone. I hope we're all doing good. I'm glad to be here this morning to discuss about an interesting topic, which is cloud security. Let's dive in. So the topic given to me was securing cloud applications in the wild. So my name is Suliaman Olubiyi, as was said earlier. I'm a network and security engineer at Interswitch Group. And this is going to be the outline of my slide from the introduction, model, and to the summary. So let's dive in. So the new reality before us is that let's take it back some 10 years ago, where the infrastructure, including routers, switches, servers, backups, are hosted locally. Locally means it is physically present, something like a data center. So that's that's the model some years ago, before the wide adoptions of cloud computing. Nowadays, companies, fintechs, financial institutions, they are migrating their application from the on-prem. On-prem means the physical location, to the cloud. Now, the same application services in terms of the web application, either an Nginx or Apache or database or servers, rightly on the physical structure, are being migrated to the cloud. So now, migrating it to the cloud has actually changed the architecture. It's actually changed the whole architecture evolution, and as well, the attack needs to be widened as well, because it's no more locally hosted again. It's on the global stage, which is the cloud service. So now, I'm going to discuss about the model when operating on cloud. So this is a shared responsibility model. So let's view a cloud like an estate. So in an estate, we have some block of flats. But in the estate, there's a responsibility for the estate owner. Same as well, there's a responsibility for the owners of those blocks. So for example, in an estate, the estate owner has a responsibility to maybe a good road network, perimeter fencing, a stable power supply, and all of that. So that's the infrastructure. Whereas for the owner of the flat itself, the responsibility is for the person to maybe his locks, his windows, maybe his access to his rooms and all of that. So same thing applies to the cloud. So the shared responsibility model has two dimensions: security in the cloud and security of the cloud. So security in the cloud means the security of your own infrastructure within the cloud. Why security of the cloud is actually the responsibility of the cloud provider. So before you start using any cloud services or any cloud account, you have to be able to factor in your responsibility. So the responsibility now dives into two: the encryption at rest and encryption at transit. So what do I mean by encryption at rest? For example, you have your database. You put it on the cloud. Now, putting your database on the cloud, if you don't encrypt it and anybody just have access to it, it's already liable to attack. So security on rest means that encrypting your backups, maybe you're using a server-side encryption, or you're using a key management service and all of that. That's security at rest. But security in transit actually means when your traffic is flowing. For example, now, you open a web browser or a web application and you saw HTTP, like hypertext transfer protocol, you just see 80. 80 means it's not secured. So which means that it is prompt to attack or injection attack or any attack. But when you put it on HTTPS, that's in hypertext transfer protocol secure, it runs using the TLS, which is called the transport layer security, or the socket security layer, which is SSL. So those two concepts move hand in hand. So when you're planning on putting your applications into the cloud, you need to be conscious of the encryption at rest and encryption in transit. So now, we've quite understand the responsibility when it comes to migrating our applications to the cloud. Now let's look at the threats when you're talking about cloud applications or cloud computing. So I highlight some key threats when it comes to cloud apps. The first one is insecure APIs. So APIs means application programming interface. Now, let me put it in a way that we all understand. APIs, the evolution of web applications has evolved from a service communication to an API based. For example, now you want to make a payment. The payment is going to do an in-name inquiry to NIPS that will validate your IP. You put your account number there, it's going to quickly validate your name. So that's an API call to NIPS. You make a payment, an API is made to the banking you are sending money to. So all those components are based on API, and they need to be secured. So putting your application out there, not secured, is already a threat. So when you are implementing your cloud, your APIs, you need to be thinking of, am I using a token-based authentication? Am I using a password-based authentication? And we have other form of security when it comes to API security. But the first thing you need to understand is that you must not expose your API. It's very, very important. You need to secure it. So the second point is misconfiguration. We've all been there before. Maybe one way or the other we made a mistakes and all of that. But it is very, very important that a mistake made on cloud is not really your local environment. It's a global service. So you need to be able to understand, for example, in Amazon Web Services, we have something we call the buckets. We call it S3 bucket. It's used to store files and all of that. So, and primarily, Netflix will run on that S3 bucket. So you could have wondered how Netflix is putting up their movies here and they're highly available and all of that. So Netflix uses the S3 bucket. So now what I'm trying to pick from there is that the S3 bucket, if you mistakenly upload in and sensitive information to the S3 bucket, it's going to publicly put it outside there. So anybody can have access to maybe your banking documents, or your sensitive document, or all of that. And it was just a misconfiguration. So we need to be very careful when you are implementing cloud applications in terms of the exposures and misconfiguration. That's why at the end of my slide, I'm going to put in some measures to this threat. So the third point here is the IAM failures. IAM failure means identity and access management. For example, now you are just an intern, or an intern just come into an organization, and you give him the full access to a whole production code base. That's a very, very bad risk. So there's something we call the principle of least privilege. So you assess and you give individual the least minimum permission for them to do their work. I'm a network and security engineer. The permission that will be assigned to me, or the permission will be assigned to me, will be based on my role. I have my colleague is a database administrator. The permission to be given to the person is going to be based on the database. Why? For example, now, a data analytical analyst, rather, he doesn't need to do anything right into the database. A data analyst needs to just read from a database, right? So the person, the data analyst, just need a read-only access to the database. Doesn't have anything doing with writing to a database, writing SQL script, writing all of that. No. But so that's the IAM failure. So you don't just give full access to people. You try to give them based on their description. Because when you are trying to move fast, you need to be conscious of not making mistakes. Because moving fast at the end of the day can just make things to break, which is not irreversible. The last point in the threat is the supply chain attacks. We all agree that an application cannot be built from scratch. You need dependency, right? You need pipe installer, you need Node.js, you need base image, you need, like, there are a lot of open source communities, open source images, packages out there. But you need to be conscious of what are you pulling into your stack. Your application, where are you getting your packages from? Is it from a censored open source organization or where? So you need to be very conscious of where you're getting your base image, your application dependency, and all of that. So now, I'm mentioning this threat, so I'm going to break it down into 4 pillars when it comes to practical events. So the first pillar is identity and network at the gates. So the reason why I'm putting this at the front is that that's the fundamentals when you're talking about cloud applications. You need infrastructure. The way the cloud is provisioned, you have infrastructure as a service, platform as a service, and the software as a service. So most organizations use the part of the infrastructure as a service. Infrastructure means that the hypervisor, the servers, the computing servers is hosted using the cloud. While you bring in your OS, whether you're using Ubuntu, you're using Windows Server, all of that, you bring it into the cloud, you put your applications there and all of that. So now, when talking about the infrastructure as a service model, the first thing is that you don't share IAM roles. It's very, very important because we are working in the same department or maybe in the same, let's say, team, but my role is different from your role. You can't share the same IAM roles with me. IAM roles needs to be very granular to the least minimum. So that I think emphasizing on IAM because it's very, very important. It's very, very, very important. So you need to be able to identify and break down things when it comes to your identity and access management. You need to be very, very careful about that because that's the first entry. Because anybody that have access to your account, they can do and undo. So you need to be able to guard that gate. That's the first thing. The second part is MFA. We all know that the password level of authentication is not secured enough. Because authentication is in like some ways what you have, what you know, and what you can see. And what I have is my password. Or what I know is going to be another level of authentication. So aside from your password, you must have another level of authentication. Maybe an MFA. We have some virtual MFA by Google, Microsoft, and all of that. And we also have some keys, security keys as well. So you need to put another level of authentication when logging into your profile or to your account. So the DevOps engineer cannot just deploy to production without having the required permission to do that. And the last point is very, very important is the VPC segmentation. So let me take it a bit expatiate further. VPC means virtual private cloud. You know, earlier before I was talking about the cloud as an estate, right? So in that estate, the VPC is just like a flat A. So I'm going to give, AWS is going to give you flat, which is your VPC. So your VPC, you must be able to segment it in a way that it is fully secured. For example, in your VPC, you have your public subnet. That will be your internet-facing applications. You have your private subnet. You have your third-party subnet and all of that. So you can't just put your database in a public subnet. which means that anybody on the public side will be able to have access to your database. So you need to be conscious of your segmentation when it comes to your VPC, your virtual private cloud account. So your public subnet, your private subnet, where are you putting your middleware, where are you putting your backups and all of that. So you need to be able to segment it very well. So now the question now is whether you have a cloud account or you're running an application in the cloud. So you need to ask yourself, who has the admin level access to my account? Who is the person that has that pseudo privilege to my account? So you need to be able to ask yourself and get the answer. And who gave it to them? In AWS, there's something we call the root account. So who is the owner of the root account in your environment or your enterprise and all of that? So you need to be able to secure your account. So now let's go to the part where developers comes in. So developers, with time, if you have worked with them very well, they like moving at a very high speed. That's developers. Just give me that features, user stories, I came up with something and everything is fine, right? So, but when you are trying to move faster, you need to be able to understand what you are pushing out there. So imagine you're shipping a code to production, and at the end of the day, you're just shipping out an outdated dependency or a flaw to the application. So it's going to introduce what we call the remote code execution vulnerabilities to your code. That's the first thing. So when you are trying to import those libraries, maybe import pandas or something, or import Node.js or all of that, you need to be conscious of what is the version you are importing and the kind of summaries or feedbacks on those kind of packages. So you need to be able to understand that. And the attack, or if you don't really implement or secure your code very well, at the end of the day, what you're going to be having is you're going to expand your attack surface area. Because at the end of the day, they can actually get to your code and try to hack into your code directly. That's what we call the remote code vulnerability. So, and also, there's something we call data exfiltration. So from your website now, there are some applications that if, I don't know, if you go to the developer tools on your Chrome, you'll be able to see the password of that login page. There's some applications like, web applications like that. So you need to be able to understand, not to be able to expose your data or your secret keys to the application. So the developer needs to be aware. Code reviews, that's why you have managers. Managers needs to, when you push your code to the pipeline, there's going to be a review before a PR. You call it a PR, pull request. So once your PR is reviewed, it's then a match to the entire pipeline to move further. So, and another thing is that we need to take care of the ownership. So you need to be, security starts from the developer itself. So you need to be conscious of, okay, are you importing your code, your refactoring and all of that. So this is a very, very important part when it comes to applications. Now, earlier before, we were running what we call the monolithic application. Monolithic applications means that on the same server, we have the application, maybe Apache, we have the database, we have the backup, we have everything on that same monolithic application. So at the end of the day, it makes things to be very slow, package dependency and all of that. But with the new technology comes in, that's the containerization from Docker. So we're able to something like map a whole application into like what we call an image. So that image, everything you need to run that image is already on that. Everything you need to run the application is already on that image. So what you need to do is the same image you use in test, you push it to production. So that's the evolution of application deployment. So there's no more dependency issues again. So as the developer is pushing the image right to the test environment, the same image after being scanned is pushed to production. So I'm not having like, okay, I'm using Node.js 14, she's using Node.js 20 and all of that. But this image containerization, you need to be able to understand how it works. Because there's something we call the base image. For every application image you're deploying, there's a base image. That base image, for example, now, I'm running a web application. I'm going to call a base image called Nginx, or maybe Alpine, or Ubuntu, all of that. I'm going to call it as my base image. So that base image, you must be able to understand, okay, this image, is it an outdated one? Is it is it patch and all of that. So you need to be able to understand your image flow. We call it Docker file. Docker file. So now the next thing now is Kubernetes. All the containers running those applications need to be managed. So we will have a whole body called the Kubernetes, called majorly for orchestration. So it manages those workloads. So they call them microservices. So for example, now I might have a microservices for payments, for checkout, for just different parts in your applications. We have their own Kubernetes services. We call them services. So now you need to be able to secure your Kubernetes, because major cloud, major fintechs now, they run their applications on Kubernetes. So there's something we call a role-based access control. They call it RBAC. RBAC means people who have access to deploy something on your application. You can just give anybody access to start deploying on your Kubernetes cluster. At the end of the day, they're going to spoil your cluster, overload it, and then your application will drain. So you need to be able to understand that as well. And the last point I'm going to be talking about the infrastructure is Terraform. So the way cloud application is coming in is that the evolutions has actually evolved from, okay, I'm going to the console, I'm creating this, I'm creating that. So there's a way you can actually modify all your application deployment from a file, including the infrastructure, right from the infrastructure to the deployment. So that's what we call Terraform, infrastructure as a code. So the same infrastructure AWS is providing for you, you can have them in a set of files. We call it a Terraform file, and deploy it to production. So you must be able to identify which modules are you pulling in from your Terraform file to know, okay, which is this type of infrastructure I'm deploying. And the problem is that this Terraform file, a lot of companies use it. It's an open source tool, but a lot of companies use it to deploy their cloud infrastructure. So you must be able to understand the templates. How are you deploying it? Are you not exposing a file? So logging is very, very important. You must be able to log everything happening to your application. For example, now, something is happening to a code at a code level. So you won't, at the end of the day, you won't be able to understand, okay, is it a latency issue? Is it a dependency issue? Or what's actually going on? So you must be able to log in the application very, very well. So the last point there is incident response plan. You must be able to be all alert. When it comes to incidents can happen anytime. For example, a server breaks down, your application just crashed. What's your contingency plan? What's your backup plan? What's your incident response plan? So you must be able to provide that. Okay, sorry for the break in transmission. So in cloud security, something there is that what you don't see will hurt you. So you must be able to have eye in every part of your application. At the login level, at the database query level, at the dependency level, the network level, the compute level, your CPU, your memory utilization, your Kafka dependency, and all of that. You must be able to have an eye. Logging is very, very important when it comes to cloud applications. Now, so everything I've said since I started my presentation now combines to what we call a DevSecOps journey. So the DevSecOps was emanated from DevOps. So we all know what we call DevOps, developer operations, and all of that. So the DevSecOps means that putting security at the middle of the DevOps. So security is not something we had later when we deploy the application. Security is something that must be initiated from the beginning of the application. So as the developer is writing that code, okay, I want to write a code for a website or something. So the person has already put it in mind, okay, I'm using the right dependency, I'm using a very good image, I'm not pulling in something from I don't know the source from. So those kind of things comes in to where we call the DevSecOps workflow. So secure the code, that means when the developer is writing the code, very aware of the security fluctuations in the code. That's very, very important. The second part is secure the container. Most applications now, frankly, most applications now are running on containerization. Most applications now, the banking app you are using, the Jumia website you are logging into, all those applications are running on containerization. And the reason is that they are very scalable, they are microservices, they are highly available. So there is no applications nowadays or a company working for people use a global use won't adopt containerization. So there is no way you use containerization. You have to use Kubernetes, because Kubernetes is like orchestration, just managing the whole container. So you monitor in real time, you scan your deployments, that is the infrastructure as a code, and your policy checks, there's a review. Monitor in real time is very, very important. That's you have the SIEM, the security, information, and event management, where you get your logs and you get your all information updated about your application. So now the desktop workflow, you can see the building, the code, the build, the plan, and the test. So that's the part of the developer. But the security still stay within it, because the security is just like an intersect between the dev and the ops. So as the developer is doing the building, testing it, is also ensuring that everything is security compliance. Why? In the ops side, is the operations side, that's the DevOps engineer or the platform engineer will be aware, okay, what's the OS vulnerability of where I'm pushing my code? Who is reviewing this deployment? And well, nowadays, companies doesn't actually deploy their pipeline directly. There's what we call a pipeline. At each stage of the pipeline, you have what we call a code review or a testing. It could be a unit testing, it could be an integration testing. So at each point of pushing a code to production, there's a lot of series of testing that would have done within that stage. So at each point, you must be able to identify, okay, as the unit testing of this code function has been tested correctly and fine, it then passed to the pipeline. So the pipeline is just like a pipeline for pushing an application from the code building to the production. That's just the pipeline in a very summary word. So in conclusion, this is going to be the summary of what I've been explaining since. The first thing is that you understand that the cloud responsibility starts with you. Either you are a developer, or you're an operations engineer, or a system administrator. So the security of that app you see outside there depends on everyone involved in that deployment, from the builder to the tester to the QA to all sort of people between it. So it's your responsibility. So don't just mean that, okay, my application is running on Azure, I don't have anything to do it again. No. You still have your responsibility to do. And another thing there is that you secure every layer, from the code to the network to the infrastructure. You must secure it. What ports are you exposing outside there? Are you exposing a vulnerable port? What kind of assets are you giving outside there? So you must be able to identify every layer of your application and to be able to secure it at the end of the day. So you build with scanning, detection, and response. You must have a very high incident response plan. You don't wait until you are attacked before you have a very good plan. So you must have, at each level of your code or of your application, you must have a threat hunter internally that is checking, okay, where are the flaws in this application? Is there any CVE there? Do you have anything there? So you must be able to understand the whole scanning, detection, and response. Another point here is automation. You can't, for example now, let's say Jumia. Jumia is running their application, maybe on cloud, for example. And there's something we call Jumia Black Friday and all of that. And there's a high surge of application requests that time, right? So if you are expecting them at that time to start provisioning a new server, to put in a new application, it won't work at that time. So that's why automation is inevitable. As a company is growing wide, automation is a must. You must be able to adopt automation in your workflow. So the Jumia app, you can easily scale. Just scale out. When it's during the time of the Black Friday, it's just scale out. And when the Black Friday has gone, it's scaling. So that's the part of automation. Be able to automate and scale when you need to scale. So the last point, security is everyone's business. Don't see it as it's just for security engineer. No. Or it's just for this InfoSec guys. Or I'm not in security, right? No. It's your own responsibility. Are you patching up your OS on your laptop? Are you doing what you need to do when you're working on a cloud applications? Don't just try to just import a package or image that you don't even have an history about. So you must be conscious of the security at every layer, starting from your code when you're building it till when it goes to production. So I think that's all from my slide. Thank you for listening.